lecture series of software engineering. So today's topic is white box testing. If you recall, in the last lecture we had already studied one technique of testing, that was black box strategy. Today we are going to study white box strategy, and I am your instructor, Ms. Shruti Rawal. So let us study today's outline. So in today's lecture, what are we going to cover? The first thing that we are going to cover is white box testing introduction. It means what do you mean by white box testing. The next thing that we are going to cover in today's lecture is basically the normal techniques that are applied while white box testing, that is statement coverage, branch coverage and path coverage. So these are the basic techniques that are applied while doing testing in white box. So let us jump to our first outline, that is white box testing introduction. Okay. So what do you mean by white box testing? If you recall, in last lecture I have already discussed in brief what was the difference between black box testing and white box testing. So the basic difference of black box testing and white box testing was that black box testing was not concerned about the internal or logic structure or the code of a software, right? Whereas when you are performing white box testing, you are actually executing the code, seeing the code and then finding the inconsistency in that code, right? So in white box testing, we are basically concerned about the code, what are the internal logic of the code and what is the local data structures that we are checking in the white box testing, right? So basically white box testing is a software testing technique in which we are seeing the internal structure of the coding and we are testing the software so that we can verify that the input and output is according to the customer's requirement, right? Now in white box testing, because we are able to see the code, we can also call it glass box testing. It is also known as transparent box testing. It is also known as structural testing because we are able to see the code, right? So this was about white box testing. Now what is the basic use of white box testing? We can use white box testing to check the code. So all the uses that are with respect to white box testing are with respect to code also. It means that when we are performing white box testing, we are guaranteeing that whatever independent path of the program we have, we are actually navigating, or you can say we are traversing to all those paths, right? We know what we mean by independent path. We have already studied this in the previous lectures, that if we have a decision in a particular program, we know that we can either follow the true condition or a false condition. So basically for a decision I have two paths. Similarly, you can have multiple paths for switch case, right? So there are different paths that can be followed in a code. When you are performing white box testing, you are actually checking that are we testing the code for every path or not, right? The next thing that white box testing ensures is it basically ensures that all the logical decisions, that is they are either true or false, are completed or they are tested, right? The next thing is we are actually testing all the loops and the boundary condition in white box testing. And the last thing is, as I have already told you, we are also concerned about the data structure, so that because we know that testing local data structure is very important. If the local data structures are not tested while unit testing, then it is a possible bug, right? So all the local data structures are mostly tested when white box testing is performed. So these are the basic uses which are code related testing, right? Now let us jump to the white box testing strategies. So in the outline we have already told that what are the things or what are the strategies that we are going to learn today. The first strategy is statement strategy, the next is branch coverage, and the last is path coverage. So let us see each of them in detail. But before seeing the statement coverage, branch coverage and path coverage, first of all we need to create a flow chart, and we will then see what do you mean by statement coverage, branch coverage and path coverage. So let us take one example. So here you can see I have a piece of code. So for these particular pseudo code, I will construct a flow chart, right? So please look this carefully. The first statement is read P and read Q. So whenever you are constructing a flow chart, you must take into consideration all the symbols, right? So for a simple statement, we have this rectangle. Okay, so read P and read Q is nothing but we are scanning two variables. So these are normal statement. So these both scanning I have written in one statement, right? So whenever in this flow chart, whenever we are writing some statement, that particular statement will be given a numeric number. So you can see when I have written this statement, I have written 1. Okay, so that is known as a node. So this statement is known as a node. It is given a numeric number. Now we know that when you are drawing a flow chart, you are going from one statement to another statement and you have an edge that is connecting both the statements. We will give an alphabet for that particular edge. So A is an alphabet that I am giving. So basically the control from first statement is going to the next statement, or here in our case there is a statement which is decision, right? Because you can see in the code the next statement is if condition. If P plus Q is greater than 100. So that is a decision, and I have written decision in which symbol? Diamond symbol. So if you can recall the flow chart symbols, decision is always written in a diamond symbol. So getting how am I constructing this flow chart? Whenever you are writing the statements, you are giving a numeric number. Whenever you are writing a control edge, you are giving an alphabet. So the first statement is given 1, the control edge is given alphabet A. Then you have this statement, that is decision statement, so it is given a numeric number 2. So after I am writing the if condition in my code, I have two possibilities, whether the if condition is getting true or it is getting false, right? So if it is getting true, so if the true condition is there, that is yes, then I am actually getting some statement. So for this control edge, what is the alphabet that I have given? C, right? So for true statement, what is the statement that will be executed for true condition? Print large. So this is a statement that will be executed if my P plus Q is greater than 100 condition is getting true, right? So for this statement, the numeric number is 3. Now one possibility is that either your if condition is getting true, the next possibility is false, but that we will traverse later on. Now after this print large is getting executed, what will happen? We know that after this is executed, yes, your if condition is ending. So for the ending, we are not actually, if condition ending is nothing, it's not a statement. So we are depicting it by a small circle which indicates end of if, right? And that control is basically depicted by D, okay? Yes, so this is an end if. Now the next statement, or you can say the next condition is if my if statement's condition is false. So if P plus Q is not greater than 100, what will happen? Then also it is ending, right? So this is basically the end if. Now after your if condition is ending, what is happening? Another if condition is being executed. So you can see in the code that only true condition for if is written, no else condition is written. So in else condition we are directly ending the if, right? And in true condition we are executing one statement. After the ending of if, we have another statement, and that is also an if statement, that is if P is greater than 50. Right, so we also have a decision in which we have written P is greater than 50. If it is greater than 50, what is happening? Yes, if the condition is true, we are printing P is large, right? And we are ending the if. And if the condition is false, again for false condition, we have no statement to be executed. So we have only statements for if true conditions, we don't have any statements for if false condition, but we have to write all the parts, right? Now you can see that this is a flow chart which is corresponding to this example. We have again given numeric numbers to the nodes, or you can say the statements that have been executed in our code, and we have given an alphabet to the control flow edges, right? Now if I want to traverse a path, right, or if I want to say that this is one path, how will I actually write a path? You can say 1A, that means you are executing statement 1, and then the control is going through the alphabet A, that is your edge A, and then you can say to C. It means your second node is getting executed and the control is going via C control edge, right? So this is how you will write the path. Okay, so for this example only we will study all the three coverages, that is statement coverage, path coverage and branch coverage, right? Now first of all let us see what is a statement coverage for our corresponding example. So this is the same example of statement coverage. Now what do you mean by statement coverage? Basically statement coverage, it means that you have to cover all the statements of your particular flow chart or of your source code at least once, right? So you can see this path which I have drawn, and when you follow this path, it is ensuring that all the nodes are covered minimum one time. How? Let us see. So the first path is 1A. It means the first statement is being executed, and then what is the control edge that we are following? A edge. So you can see in the path also I have written in statement coverage 1A, right? After 1A, what is the path that I am following? Yes, 2C. So second statement is being executed and the control edge that is being traversed is C edge, right? So 1A, then you have following 2C, then the next is 3D, right? So the third statement is executed and the path that you are following for the control edge is D, and then you are following E, right? So that is the control edge which is going to the next if condition. After that you are executing the path of traversal, that is 4G. Okay, so the fourth statement is being executed and the control that you are actually following, that edge is G. So 4G, and the last in the path is the statement fifth that is being executed and the control edge that you are following to the last end if, that is H. So this is the basic path which I have followed in statement coverage. Now you can see what are the actual statements that are being executed in our source code. They are basically 1, 2, 3, 4 and 5, right? So you can see in the path also all the nodes are covered at least once. So that is the basic aim of statement coverage, that while you are performing statement coverage, it is mandatory that all the nodes are being executed minimum one time and all the true conditions are followed, right? So it is okay if you are not following the false condition, because in statement coverage it is recommended that you follow all the true conditions. So here also we have followed all the true conditions and we have executed every node minimum one time. So this is the path that I have written for statement coverage, right? The next coverage is basically branch coverage, and in branch coverage the main aim is basically to follow all the node minimum once. That is the main thing that we have to follow in branch coverage also. But along with that, in branch coverage with the true conditions, we have also to cover all the false condition. So you can say basically that your statement coverage is a subset of branch coverage, in which all the paths that were covered in statement coverage should be followed or should be included in the branch coverage, but the extra paths that are actually having false condition should also be covered in the branch coverage. So here when I am writing the path for branch coverage, you can see the first path, that is 1A, 2C, 3D, E, 4G and 5F. That was the path that was already covered in statement coverage, right? So that is to be included in branch coverage, but along with that path, the next path that was the false condition path, which we had not explored or we had not included in statement coverage, is included in branch coverage. So that is the false condition. So 1A, the next is 2B, the next is E, and the next is 4F, right? So that is the path that was not followed in statement coverage. So in basically branch coverage, you are following all the true conditions as well as all the false conditions, right? And all the nodes should be executed minimum one time. Okay, so now let us see the last type of coverage, that is path coverage. And basically path coverage is covering all the paths irrespective of the true or false condition. It means if you have two decisions in a single source code, you have to cover all the possibility, that is the first true condition with the second true condition with the false condition with the true condition, false condition with the false condition, right? So irrespective of anything, you have to cover all the paths. That is known as a path coverage. So in short, all the independent paths that you have covered in branch coverage should be covered in path coverage, along with all the other possibilities that are not covered in the branch coverage, that also you have to cover in the path coverage. So already we have covered two paths in the branch coverage, that are the first two paths. Now there are two paths that are remaining to cover, that we will cover in path coverage. So you can see the path that we have covered here in the path coverage is 1A, okay, then you have 2B, then you have E, then you have 4G, and then you have 5H, okay. So the first false condition and the second true condition, that is one of the path that was not covered in the previous true coverage, that is it was not covered in statement as well as branch coverage. So that is covered in the path coverage. Along with that, we have a fourth path that was also not covered previously, that also we have to cover in the path coverage, that is the first true condition and the second false condition. So that is a path that is 1A, then you have 2C, then you have 3D, then you have E, and then you have 4F, right? So this is the path that was remaining. So in path coverage, for this particular example, we have four independent paths that we have to cover, right? So this was about path coverage. Now you have studied three of the coverage, that is statement coverage, branch coverage, and path coverage. After finding all the independent paths that are in all of them or all the coverages, what you need to do? You need to perform white box testing in all these particular paths. So you have to enter the test cases such that these individual paths are traversed during the execution of your code, and you have to see whether that particular path is following the required output or not, right? It means the expected output should be equal to actual output for every path. If it is not, then it means your test case has an error and it is failed, right? So it is a possibility that the developer has to see some sort of inconsistency in the path where you are not getting the expected output, okay? So yes, this was all about today's lecture. Thank you.